Hello and welcome to AIMLDL, and today we are going to make an artificial neural network using our very famous Perceptron algorithm to predict the bitwise values totally from scratch using Python. So let's start. The Perceptron algorithm. In machine learning, the perceptron is an algorithm for supervised learning of binary classifiers. It is a type of linear classifier, that is, a classification algorithm that makes all of its predictions based on a linear prediction function, combining a set of weights with a feature vector. First introduced by Rosenwald in 1958, the perceptron, a probabilistic model for information storage and organization in the brain, is arguably the oldest and the most simple of artificial neural network algorithms. The perceptron is still a very important algorithm to understand as it sets the stage for more advanced multi-layer networks. We will start this video with a review of perceptron architecture and explain the training produced, called the delta rule. We will also look at the termination criteria of the network when the perceptron should stop. And finally, we will implement the perceptron code in Python. If you have taken an introductory level computer science course before, you might already familiar with bitwise function. Bitwise operators and associated bitwise dataset accept two input bits and produce a final output bit after applying the operation. As you can see, here are the three datasets, which is AND, OR and XOR. We often use these simple bitwise dataset to test and debug machine learning algorithms. If we plot and visualize AND or XOR values with red circles being 0 outputs and blue stars are 1 outputs, you will notice an interesting pattern. Both AND or OR bitwise datasets are linearly separable, meaning that we can draw a single green line in the data, whereas in XOR it is impossible to draw a single separable line which separates the two classes. Here you can see I have put a question mark instead of a linearly separable line. Ideally, we would like our machine learning algorithm to be able to separate non-linear classes. Here you can see these are the two non-linear classes, as most datasets encountered in the real world are non-linear. Therefore, when constructing, debugging and evaluating a machine learning algorithm, we may use bitwise values as a design matrix and then try to predict the corresponding y values. Architecture of perceptron network. There exists connection and their corresponding weights W1, W2 until Wi, that is W4, from the input Xi, where I is from 1 to 3, is to single output node in the network. This node takes the weighted sum of input. Here you can see I am taking the weighted sum of inputs and passing it through a step function. The perceptron outputs either a 0 or a 1 for a class 1 and for class 2, that is, and here our class 1, this is my class 1, is 0 and my class 2 is 1, and the step function is giving me two classes, which is 0 and 1. In the original form, perceptron is simply a binary two-class classifier. The pseudocode for perceptron training algorithm. The actual learning is taking place in 2B and 2C step. So let's start. I am taking a very small example. Here you can consider x1 is equal to 1 and my actual output will be 0, and I am taking bias as 0. Usually we consider bias as 1, but here I am taking bias as 0. Okay, now let's move further. Here I am passing my product of x1 and w1 from my activation function. Here you can see my activation function is a step function which will give 1 when my output will be greater than 0 and 0 when my output will be less than 0. Okay, so finally my y predicted value will be 1 as my output is greater than 0. So now you can see the error, which is the difference between the actual and the predicted value, is minus 1. Now what I will do, just focus here. I will pass the new my old weight and my error through a new equation, and I will get my new weight as 0. Here I am considering my learning rate, which I have already told you in previous video, which is the number of steps in which I have to wait. Means this will determine that in how many steps I will move to the new weight. Okay, so here my new weight is equal to 0. So again I am starting from here and I am getting the new predicted value as 0. So as you can see, now the error has been omitted using the proper perceptron algorithm, and this makes us closer to the correct output. Now let's talk about learning rate. For example, if I am taking my learning rate as too low, there is a possibility that I will reach the minimum point, but it will take a large amount of time. But if I am taking my learning rate as too high, there is a possibility that I can omit the global minimum or a local minimum. So we should take a just right value of learning rate which swiftly reaches the minimum point. Now let's implement the Perceptron in Python. First of all, you need to make the directory in the following manner. Create a folder, name utilities, and then inside a file create a Python file init.py, and a folder. It is a folder name neural network, and inside that create an init.py, and inside that create a Python file Perceptron. Now let's move on to coding part. Take one example. First of all, create a folder named Perceptron. I've already done this. Inside this, create a folder named utilities. You can change it according to your need. And inside this, create a file named NN, which we can consider as neural network. And inside this, create two files, init.py and perceptron.py. And here also you have to create one init.py. Okay. So now let's start. Okay, now let's start. Here I have imported the numpy, and I have already written some part of code. Here I have created one class perceptron and declared the init. In init function, it's basically we always consider init as self function where n are my number of columns in a weight matrix. Okay, and alpha is my learning rate. As you can see, we have already discussed about learning rate, and here I am declaring the weight matrix using the random values from the numpy library. Here it is a I am using the Gaussian. Here I am using the weight matrix as Gaussian distribution, and I am considering alpha as an learning rate. Okay, now here I have declared one step function which is simple activation function, which is returning 1 if my input will be greater than 0 and else 0. And now let us make the very important function, which is our fit function. You may have seen in different sklearn libraries and different libraries model.fit, model.predict, and this is that fit function. Here I am taking the two inputs and outputs for training the model, and I will iterate it over 10 loops. Okay, so let's loop over the desired number of epochs. Let me write what we are going to do. I'm going to loop over the desired number of epochs. So here I have declared the for loop for the epochs, number of epochs. My loop will go from 0 to 10. Okay, now what we have to do now is to iterate over to each and every data point. Okay, individual data point we need to pass on through the every individual data point. Okay, so for example I am taking the x comma target in zip xy, right. Okay, I have taken x to the target. Here I have taken two variables, and these two are my input and the predicted actual output. This is my input and this is my actual output. Okay, now what we have to do, we have to take the dot product. Let me comment it. Now what we are going to do, we are going to take the dot product between the input and the weight matrix. So I have already declared the weight matrix here. Okay, so my predicted value will be the dot product between the my input value and my weight matrix. Okay, here x is my input variable, and after passing it through the step function which I've already declared here, I'm getting the predicted value. Okay, now what we have to do is we have to update our weight. Okay, so what we will do, if my predicted value will not match to my actual output, so I will update the weight matrix to achieve that task. You can see if my predicted value, which is this, will not be equal to the target, and what the target here is my y, which is my actual output. If it is not matched, then we will calculate the error. Okay, and we will calculate the error and update the weight matrix. So here I have done the declaration of fit function, and now we will move on to our predicted function, def.predict. Okay, here I am considering bias as my true and sure input is a matrix, and if it only work if my input will be a matrix. Okay, here I have using the at least 2D function of numpy. Okay, now we are entering the we are making one bias column, if at underscore bias. Okay, now what is bias? Insert a column of 1 at the last entry in a feature matrix. Okay, I am entering the bias values in the last column. Okay, as a feature matrix. Okay, now let's return the final output. So here I am predicting my actual okay, so here I am predicting my final output using the final value of w, which is derived using fit function. Okay, here this is, you can consider as the training part, and here you can consider it as a prediction part. Okay, we will move in the further code, then you will get to know it in more detail. Okay, now let's construct our prediction for OR bitwise operation. So first of all, I am going to construct the OR dataset. Okay, let me, here I am declaring one input array. These are my particular dataset. These are my output for corresponding inputs. Okay, now we are going to train the perceptron. We're going to train the perceptron. Okay, okay, so here you can see I have passed the input with learning rate to my perceptron function, Now I am fitting those in my fit function which I have declared earlier. Okay. Which I have declared earlier. So now it's time to test the perceptron. Okay, I'm testing the perceptron. Okay, print info training. So here I am going to loop over each data point. Okay, so here you can see ground truth is a predicted value पर देते हैं, actual लिख देते हैं. Okay, so here you can see I am passing my input which is x, which is x, and I have taken it as a x variable, and through this I am predicting. Let's run the code. Okay, so here you can see my OR model. My actual output is 0 and prediction is 0, so it's correct. Now let's see it for AND dataset. And data 0 0 is 1 0 0. Okay, 1. Now let's run this. Okay, so here you can see my actual value which is y is 0, and my prediction value which is I've got from the predicting x, it's called prediction. Okay guys, so here what we have done is perceptron algorithm, which is really an important one, and using this what I have actually did here is single layer perceptron neural network. So in next video we will go through the back propagation and multi-layer neural network so that you can use it for the non-linear data sets also. So after this you can save these codes. You have to save these codes, or you can form your own library using this, and I have given the link of the code in the description. So now let me save this code in the different. So now I'm going to save these codes in those folders. So let's just copy the class code in that and save it to. Okay, so now I'm going to save these codes in different folders which I have saved. Save this code. Save this code in perceptron.py. Make it a final. Let give it a final touch. Perceptron.py. Okay. And perceptron final is perceptron or the final or an AND bitwise operation. You have to copy this code in this file. Okay, so it's done. As we have kept it in a folder, so just write from utilities.nn import perceptron so that we can import the functions in perceptron or py. Okay, I think I have did some mistake. Yeah. Okay, perceptron dot or here. Okay, so here is my final code, and here I have saved the model. So finally we have created a project to perform bitwise operations using simple numpy and the mathematical operations. So I hope you have enjoyed the video. If you enjoyed, please like, share and subscribe. Thank you.